It is get the sound. All right, can we start? Yeah. Okay, let's start it. Let's start. All right, can we start? Get your attention. Okay, who remember what did it look like? Y equals x squared. We learned last semester. What does it look like? Parabola. Let's give Amy 1 point. That's it. And then last unit we just did the test. What is y equals to square root of x look like? Oh boy, you remember last semester, but you don't remember the one just last Wednesday? Oh, what does it look like? Give me some hope. Give me some hope. We just did the test, people. Yeah, I know, but I'm waiting for. I know. Like, only Amy remember. Roughing exponential function. Okay. So today we'll learn a bit something about y equal to. What did exponential function look like? If you took algebra 1 already with Mr. McLean, Mr. Goza, you remember what does it look like? Okay, all right, that's fine. That's fine. So y equals to a b x. Does it ring any bell? No. A little bit. If you took algebra 1 with Mr. McLean or Mr. Rosa, this is that what we learned. Because I'm teaching algebra 1 right now too. Okay, so a b to the power x. Okay, that's is called exponential function. What is b? It's all gone. You forget everything. Huh? What is b? Yeah, kind of ratio. Something about constant ratio. Does it ring any bell? No. Okay. Constant ratio. Okay. What is a? A is similar to y(x) plus b. B is the y-intercept, so a is also y-intercept. Okay. Y-intercept also means the initial value. Yeah, initial value. Initial value or y-intercept? Y-intercept. What does it mean, y-intercept? Can someone remind me? Y-intercept is? Huh? No, just say it. Don't worry. Don't worry about right or wrong. Just say it. What do you think? What does y-intercept means? Ramon, what did you say? What did you just say? Something about y, because that's what they call y-intercept. What about y-axis? What is y-intercept? Karen, Adam, Richard, Alex, Ellen, Matthew. What is y-intercept? Come on, we talk about this many times. What is y-intercept? How about x-intercept? Okay, y-intercept is the point on the y-axis. Okay, the point on y-axis. Let's give me track 1 point. Point on y-axis. Okay. Now for the exponential function, only two main types. Okay, only two. They either look like this. Two main types. So they either look like this or look like this. All right. Who know the name? I know this is kind of new, but if you only took the answer one, then you, for sure you somehow you still remember the name. No? Okay, never mind. Row function. Then what is the other way? What is the other one? Opposite of row. Come on, give me some hope. Row function and kind of very close. Huh? Huh? You two kind of very close. Like one decline, one decrease. Row function and I just heard something. Decay function. Does it ring any bell? Decay. Whoa, that decay. Decay, that I will tell you on the real life, we're actually using this decay. So row function, there are only two main types. One is row function, and the other one is decay function. You can tell decay is decreasing, going down, right? Like we just said it's decreasing, or I may say it decline. So decay. Why are you using the word decay? So actually, when I learned this, when I learned this kind of function, I kind of wondering, oh, when do we gonna see this? How does it benefit on the real life? Actually, we're using that a lot in the real life. So first for the bank, we're using that for the compound interest or interest, whatever. Okay, this is the interest you got for every year and annually or quarterly for some reason. And then you also do you know census? Do you know census? Come back here. Come back here. Do you know census? The populations? You never heard of it? So census is like organization. They get the population. Right. They're gonna count how many people so the population of the world as well. So census they also using exponential function. Okay. What else? I forgot what's it called. Do you know what it's called? Like they try to see how old is the wood, like carbon something. Do you know that one? Like they cut the wood in the middle, and then they try to see how old is it.
Oh, the rings in the tree trunk.
Yeah, the ring is based on the carbon something. Does it? Do you know? Have you heard that? Never?
Or like when you cut the tree and
Yeah.
you see the line, see how old it is.
Carbon something. Yeah. So carbon something. They're also using exponential function. Okay. Decay is using when they testing some animal as well. They try to testing they decreasing but decreasing in exponential. They call decay. Okay, so a lot of application using this exponential function. Okay. Now next question. How do I know if I look at the exponential function? How do I know when is it row, when is it decay? Oh, I let look know where to look. Good. Jasmine. They both actually they both have left and right. One going up, one going down. But yeah, that's when you look at the graph. But when you look at the function, that's what I meant. I think I left out. Oh. Yeah.
You see
Alex. Okay. Okay, so let's go. When do you know it's exponential function going up? Oh wait, growth or when it's decay? It's right there. Yeah. It's not a constant, but yeah, constant ratio, right? You mean constant ratio? Yes. When b larger than 1, it is growth. Okay. So this is when b larger than 1. And when do you know it's a decay? It's not only less than 1, but it also needs to be larger than 0. Yeah? Look at here. It needs to be between 0 and 1. So it not only needs to less than 1, but it needs to be positive, like larger than 0. Okay? So think about the number between 0 and 1. What does it mean? What does it mean when a number between 0 and 1? That means what kind of number you're looking for? Yeah, decimal and fraction. Very good. Give give 1 point for Alex and give 1 more for Amy. Fraction and decimal. Yeah, you should look at the poster right here. The other period, let's look at here, they get point. That's what we're teaching Algebra 1 right now. So you actually learn what we learned in Algebra 1. Not to make you feel bad, but just so you know that it's not that hard. Okay, so you can, if you think it easy, then easy. But you just set yourself that, oh, this is so hard, this is so difficult, and it's just make you harder to understand it. Okay, all right. So there are two other type, but they're not the main type. I want to ask you why. Okay, there are other two type, but why they are not the main type? You will tell me. Okay. They look like one. They look like this. The other one also look like this. All right. Okay. Look at this four function. Why these two are the main one, but this one is not? How can you get this graph? How can you rewrite this graph from the main one? Who said that? Okay, Ramon, what do you say? You just flip it. Yeah, did you see that? This graph right here, if you flip over the axis, you got this one. Very good. Let's give Ramon 1 point. So this one you just flip from the row function. Row function. Flip over x-axis. And the other one, what do you guess? Emily? Flip from where? From what function? From the k function, flip over the y over the x. Very good. Let's give Emily 1 point. The k function, flip over x-axis. Make sense? So that's it. That's the only we need to know. Now we can graph it. Graph it very fast. It's only. Did you want step by step? I believe something that you think is maybe your learning style. You like to step by step. Only literally just 2 steps. Okay, let me write down. Yeah, question.
You forgot to put the y-axis, the two x-axis on the bow.
Which one?
There's two x-axis. There's no y-axis on the two other types.
Oh, they actually both flip over axis.
Oh.
So I flip this one. I flip this one over the axis. But this one I flip this one. Okay. Yeah. So they both flip over axis, but it's a different one. That's why I wrote right here. The k function flip over axis. This one is row function flip over the axis. But that's a good point. That's a good observation. So they actually both flip over the axis, but it's a different one. This one is from the k. This one from row. Yeah. Good question. Good question. Carbon. Oh, carbon footprint. Kind of. Yeah, I think carbon footprint. Yeah. Yeah. Then look at the range to see how old is the wood. Yeah, that's the one. That's one. So that's why they use the k function. Yeah. But I didn't know anyway. Okay. That's no point. I didn't know anyway. Okay. Okay, step by step. Only 2 steps, literally. Only 2 steps. First step is draw the horizontal asymptote. I will tell you what is this, okay? All right, horizontal asymptote. It's the horizontal line. That's the graph is never gonna touch it. Okay, so let me write it. Okay, actually let's write the definition for that. So horizontal asymptote. It is the line that, okay, let me move this one. The line that a graph approaches more and more closely. Okay, more and more closely I will show you what is this. Okay. For example, the horizontal asymptote for these two is right at the axis. So there are a couple of things I want you to know. Be aware when you graph this. First, the graph can never touch the line. Okay. If somehow you just do so fast and then you cut the line, well, yeah, I want to take point off because that can never happen. Okay. Second thing, when you make it this one, don't bounce back like this. Don't make it bounce back like this. Okay. You need to keep going to along the exit like this. Okay. Don't draw it like bounce back. That doesn't make sense. They're going to be wrong. Okay. Any questions so far? Are we good? Okay. Oh, do you know? This is we're talking about in period 4. This is also the application of exponential. Let's think about how many generations, how many parent, grandparent, great grandparents, so that you was born, so that you can born. Okay. Okay. Let's say. Okay. You can know what I'm talking about. Let's say this is you. Okay. Yeah. You have a long leg and long hand, long arm, whatever. Okay. How many parents do you need so that you can born? 2. Makes sense, right? 2. Now, your parents, let your mom. How many grandparents so that your mom can be born? 2 again, right? So this one also have another 2, and your dad also have another 2. For your grandparents, how many? Another 2. Now look at this. Look at how increasing, how fast it is. Oh, this one only have 1. Oh, like you adopted. Oh, I just adopted you. Okay. Anyway. Okay. Did you see how the number increasing? So this is 2. How many is it? How many person here? 4. How many here you did? 8. Okay. And it keep going to 16, 32. Actually, it's going to be 2 square, 2 cube, 2 4. That's exponential. Now, if you want to find, let's think about this. How many grandparents, how many person we need in 20 generations so that you can born right here, like you can survive, you can exist right now? How do you do the calculation? 2 to the power 20? Can you? 19? Yes, fine. Can you use calculator to give me a number? Anyone? Using calculator, give me 1 to 2 to the power 20. That's the amount of 20 generations person that we need so that you can born right now. Oh, okay. Hold on. 1 million. Yeah. 48,576. Do you see that? In order you to be here, you to be born, we need 1,048,576 people. That's great. Is that like mind blowing? So yeah, you should be grateful. A lot of people certainly gonna be here. Well, still, even though you're adopted, then you still need 2 biological parents, but you should not know them. Yeah. Well, we're talking about biological. We don't talk about like non-biological. All right. Anyway, where were we? Now we got lost. Okay. Draw the HA. What else? Do you know what the HA now? It's a line. Okay. It's a line that the graph approach more and more closely. Like this line right here. This line right here. Okay. Oh, I think that's a good example. Just keep it there. Okay. All right. Next step is, let me ask you this. What is one thing, one tool? I think I asked you many times about this. That when you want to sketch the graph, you always can do this to sketch the graph. T-table. Yeah, that's good. 1 point meter. So T-table is the tool that you can handle everything. Whatever graph you did, you can just using a T-table, you can graph it. Okay, let me write down. ASYMPTOTE. asymptote. Okay, so t table. What is the three number that we did for the square root? 0, 1, 4. Good. All right, now in here. Oh, why 0, 1, 4 is important? Why I asked you to keep doing 0, 1, 4? Can someone explain the reason? Do you remember reason? Just me? Square root? Perfect square? Right. But why? But I can choose 9, 16, 25 as well. Why I specifically asked you to do 0, 1, and 4? That's reasonable, but not the main point. Oh, remember, I only ask you to do 0, 0.4, 0, 1, and 4. Because if you do all the number, that's not represent correct graph. Well, it not represent the whole graph. So here, let's remind it. Do you remember the graph square root is like this, right? 0, 1, and 4 showing you that is directly on the curve. Remember I said this? If you're finding all the number, they're gonna be along this line like this, but it's not showing you where the curve is. It not represent the whole graph. So same thing for this graph. I want you to find 3 number because this 3 number going to show you right at the curve like this, right at the curve like this. Okay, what are those 3 numbers? I'm telling you right now. This is -1, 0, and 1 on the power. Okay, on the power. So okay, how about this? Make the power become -1, 0, and 1. That's it. 2 steps. Oh, if you want, the third step is sketching. Yeah, sketching. So that you remember you need to sketch because they're asking you to wrap it. Okay, let's do a sample. You will see how this step by step gonna help you. So y equal to 4 to the power x. Okay, let's do this. Stop me anytime you have a question. Oh, the okay. Oh, excuse me.
Please do right.
I know. It's like you. Okay, you make the point. Okay, let me change it. Better? Okay. Hi, Amy. Okay, sure. Okay, what is the first step? You need to draw the horizontal asymptote, okay? If you don't see any number outside here, that means it's still x equal to 0. Maybe, okay, maybe just write down. Up or down if there is another constant. You will see later on about this, up or down if there's another constant. That means you can see some +1 or -2 out here. That is the horizontal asymptote. But if you don't see anything, that means the horizontal asymptote is just the x-axis, the x equal to 0 right here. Okay, that is the HA, x equal to 0, horizontal asymptote. Now the last step you need to do, see, only 2 steps, the first step and last step. What is the t table? What is the value I should put in the t table? -1, 0, and 4. Where did I have 4? Only 3 number, -1, 0, and 1. Okay. Oh, now negative power. I hope that someone remember this. So I'm gonna plug in -1 into the here. What is 4 to the -1? See, I knew it. What is 4 to the -1? Who say -4? Great. Please don't. Okay. I saw a lot. Oh, you're about to raise your hand? Don't. This is not -4. Okay. It is not. It is not. What do we do? Remember, we flip. Do we flip the 1 or we flip the 4? Both. Adam, what do we flip? What do we flip? Huh? Flip the 1? Knew it. I knew it. That's why. All right. You flip the big number, the 4. Okay. 1 over 4. Do you remember the property of x to the power negative 8 equal to 1 over 8? I mean 1 over x over 8. You see, even me making a mistake. 1 over x to the power 8. Remember this? Or if you have 1 over x to the negative 8, what does it become? You flip it to make the negative become positive. So x to the power 8. Yeah. We just recall. I think some of you do the project property exponent, similar to the one right there, property exponent. So this is also one of property. Okay. Now 0, 4 to the power 0 is 0. Yeah. Oh my God.
Wait, what?
Everything to the power 0 is 1. Keep that in mind. Alex to the power 0 is
1.
it's still 1. Okay. Everything to the power 0 is 1. Okay. 4 to the power 1 is, I hope you don't use calculator for this. 4. Everything to the power 1 is nothing. Okay. So now we have 3 points already. Remember I said this 3 points represent right at the curve. So that's why I need you to choose this 3 points. Yeah, question. Yeah, T table is to get the point on the graph. Okay. Huh? Okay. Negative 1 and 1 over 4. So negative 1, 1 over 4, let's say it's going to be here. 1 over 4 is about, it actually 1 over 4 is 0.5, 0.25, right? So 0.25 here, so 1 here, the point right here. So 4, 1. Oh no, 0, 4, 0, wait, 0, 1, my bad, 0 and 1. And then 1 and 4. Okay, 1. Oh, so you got to be go up here. Let me move it a little bit. So 1 and 4. 1 is here, so 4, 2, 3, 4, right here. Yeah, that's it. Only 2 steps. Well, the last step you need to sketch it, but there are only 2 steps, literally 2 steps. Negative 1, yeah, it's negative 1, yeah. But did you see that this 3 point right on the curve? If you find some other number, they are along like over here or they are up here. They're not gonna show you how the graph look like how we expect the turn, okay? How we make the curve. That's why please do this 3 point, okay? Any questions so far? All right, now the next one I'm gonna let you do in the middle whiteboard. You get some point, okay? So make sure you understand what's going on here, okay? All right, let's do second example. Y equal to 2x plus 1. All right. Now the HA is not x equal to 0 anymore, but it is 1. Good job. You got it. Okay. 4 minutes. Let's go. 4 minutes. Do on a mini whiteboard. Do a mini whiteboard. The step by step is draw the HA first. And then make the T table. Choose the numbers so the power going to be -1, 0, and 1. Group the power X.
Yeah, the constant is on the
Oh, okay. So we
Yeah.
just did find the.
Yeah, make sure you write X as a power. A little power on the top, not 2 times X, okay?
not sure myself.
Yeah, it's 1 over 1. But also, this 2 to the power x, that's what they call exponential. X is the power. The way you write it, it look like multiplication. Yeah, the 2 times x. No. Remember exponential. Exponential means the x is the exponent. Think about that, okay? Exponential means the x is the exponent. So don't write like 2x. 2x means multiplication.
I just wanted to be calculate that and I did all that.
So what is the question?
So the one HA going to go up by 1, right? So they cannot go across that one. So just choose -1, 0, 1. That's good. That's correct. What do you asking? Oh no, just plug in. You can do that one, but you can just plug it in here and calculate what the whole thing here, and then that automatically bring up for you already. Yeah, that's good. That's a good question. So keep the homework at your record. Yeah, the route cannot touch it. Give it forever. Don't lose it. Someone forgot the 8 hours last time? Well, you should keep it for your, because we're gonna have a final. Couple seconds left. You finish? One more time? 1 minute? 2 minutes? 2 hours? What day? Next year? Okay, next year. Sure. 1 minute, let's go. Let's draw the HA, okay? What is 2 to -1? Yeah, you can. It's outside.
Oh,
So that means we have 1/2 as well. Let's put it outside. Make sure you draw the HA, okay? Draw the line. I want to see the line so that I know that you understand it. Where's the line? That is your. Good job. So, okay, what is it? The 1, right? This is -1, 1.5. Is it going to be lower than 1 or higher than 1? This line is 1, right? Yeah. Okay, good. All right. Are we done? Come on, are we done? Okay, wake me up when you're done. Oh, I saw some people already done. Okay, how about this? Okay, we're gonna count 1, 2, 3, raise your ball, okay? Just raise your wall. No matter what you, I want you to see where you right now. So whatever you have, just raise your wall. I'll give you more time. The next one. I want you to see where you right now. That's good. So make sure you draw the HA, the line. I want you to see the line too. Okay. Why you're kind of weird? Okay, Amy, you ready? You don't. I don't see you have the line too. Okay, give Emily 1 point. Auntie 1 point. Vivek 1 point. Adam 1 point. Jasmine, you have it? Okay. Yeah, that's it. After the lecture, you're gonna go to the last. I think this is Santiago wants to see. Okay, let's do it. Where is the horizontal line? Where is the horizontal line? At 1, right? Now you see +1. That means x is 1. That's the horizontal asymptote. So x is 1. This one is the HA. Okay. That means the graph, no matter what portion is it, they can never cut that line. Keep that in mind. Okay. Now T table, what point you want to choose? -1. What else? 0 and 1. Okay. So if I plug in -1, let's see, what do I have? -1 here, +1. What is 2 to the -1? Is that -2? 1/2. Okay. 1/2 plus 1 is 1.5. Okay. 0. So 2 to the power 0 plus 1. Everything to the power 0 is 1. 1 plus 1 is 2. 2 to the power 1 is 3. 2 to the power 1. Oh, you add 1. Okay, got it. So 2 to the power 1 is 2. 2 plus 1 is 3. So now you have 3 points. Just plug it in. That's it. Let's see. So -1 is here. No, -1 and 1.5. 1.5 is larger than 1. So it needs to be above the line HA. Okay. 0, 2. So this is 1.5. 0, 2 right here. And then 1, 3. 1, let's say 3 is right here. So the line is going to be like this. Okay. A lot of you got it right. But next time, make sure you also draw this HH for me. Okay. Yeah. Just draw the line, I know. Yeah, but that's a good question. Yeah. Just draw the line, I know what you mean. Okay. That's good. Are we good? Chamber 1. All right. Uh-oh, that's a negative. 4 minutes, that's all. I'm gonna let you do by yourself a lot for this one, because this one is straightforward. That's not tricky. This is not tricky. Yeah, you don't agree. And don't worry if you don't really have time to copy it over to your notebook, because I'm gonna send you the note, okay? What? Wow. Oh, yeah. After the lecture, we will try to finish some. Where is the HA? Try. See this number? Good, right? So that means the line, the HA, the horizontal super is. Well, you need to do each of the line that we know the route label. Okay, now this is good. I've got the negative 1 to the x. Copy everything except the x and put negative 1. Let's see what you get. Right. No. So negative is here. Then you have a negative 2 negative. It is negative and negative 1 is yeah, it's just, Jose, try it. Jose, try it. Try it. No phone. No phone. One more minute. So if you make any mistake here, I think mostly is because of the T table. The T table is the one that you're going to mess up because that's a lot of calculation. You need to be careful. Negative over there. All right, you count 1, 2, 3. You done? Yeah. I get nothing. Yeah. Yes. Amy, you done? Emily, you done? Yes. Oh, you want one more minute or what? Okay, let's just do it. Okay, 1, 2, 3, everybody, raise your ball. Let me see, where are you right now? Okay, at least you know how to draw the HA. Good. That's great. Parabola, no straight line, no linear, okay? All right, okay, now Amy ready? Matthew, Alex, Mitra. Amy very close, but the other side, I think you mixed up a calculation. That's why you got the parabola. Remember, parabola only for quadratic. When you see something x squared, okay? Or straight line is only when the linear, okay? Now let's do it. Where is the HA? Emily, where's the HA? At some point. X equal to 2, right? 2 right here indicate that x equal to 2 is the horizontal asymptote. Okay. Now T table. What number you want to put in here? Still the same. Very good. And let me help me out. So 3 to the negative -1. I know some of you for sure making a mistake. Okay. Did you see the negative right here? And you see the negative that's already there. So you should have 2 negative. Negative and negative become positive. So 3 to the power 1 plus 2 is 5. Now 0. -0, right? Or negative is already there. Plus 2. -0 is still 0. So 3 to the power 0 is 1. Oh, you answer. You mean the answer. Okay, got it. You're fascinating. All right, thank you. All right, that's sweet. Bye, thank you. But it's still my last name, bro. Last name. What is my last name? Oh boy. We spent 6 months together. Okay, what is my last name? How many E? Don't look anywhere. Don't look anywhere. They put 2E. 2E is Korean. Is it? Did I say that?
Yes.
2E is Korean. That's how you know. 1E is Vietnamese.
Oh.
Annyeonghaseyo. No, I'm Vietnamese. I'm Vietnamese. And then you see also have LI. LI is Chinese. Yeah, they both say Lee. That's why. That's why I refer to call Parker because. No, it did not. It's already there. I know for sure you're gonna make. Also, my email then too. To make sure that you know I'm 1E. Okay. Anyway, I'm gonna wipe out though. Anyway. Okay. Okay. If x equals to 1, so you have negative 1 here plus 2. What is 3 to the negative 1? 1/3 or 0.3233, right? So when you plus 2, this case you can do estimate because you want to put on the graph. So like 2.3 something. Okay, let's give mutual 1 point. Very good. Negative 1 here. Negative 1 and 5, 2, 3, 4, 5. So right here. 0 and 3. And then 1 and 2. So 2.3. So this line is 2. So 2.3 is a little bit above it. Okay. That is the graph. Now, let me ask you, is it decay or growth? Decay. Well, you said when the number is larger than 1, then it should be growth. Why is it decay? The number 3.
The negative.
Exponent, negative exponent, what does it mean? It actually is not 3. It actually, what?
1/3.
1/3, right? Negative power, so even though the number is 3, but because the negative actually is 1/3. Is 1/3 less than 1? Yes, I hope you say yes. Yes. Okay. So that's why it's a decay. Okay, you can say the decay. Let's give Emily 1 point. Decay because 3 to negative 1 is actually 1/3. Okay, so the function is 1/3 plus 2. Yeah, because this negative is you flip it to make it become positive. All right, you're almost done. Just 2 more. And each of them have A, B, C, D, E, F. Okay, let's do it. 5 minutes, let's go.
I don't know how to do these, but not graphing yet.
What is the HA? Make sure you put it on the trash, okay?
Oh, yeah. That's why I told you it's not there yet.
Negative 1, you got it. I'm sorry. Do it. Maybe after this one, maybe. But I want to do so. Okay, everybody pen. I have 135 students. You have only one teacher. The teacher comparing to 135. So sometimes I may forget. Right? Right, Jason? You got it. You got it. 1.5 minutes. Try it. Try it. Try it. First one. What did you do, Ruby? So strong, yeah. So this one a little bit tricky on the calculation. Okay, the t table. When you plug in the negative number, it is already negative there.
Zero.
It is wrong. You have two negative, yeah. So now you have only negative 2 minus 1. What is the negative 2 minus 1? There we go. Ooh.
I got 4 too. I don't know. I don't even know how to do this.
You're not the only one. Okay. You're not the only one. Let me see. Wow. Interesting. I don't know. Okay. All right. All right. That's one thing. Let me see if someone got it right. Oh no. I just said no problem. And then I may just give me another parabola. Remember, parabola only for quadratic. Okay? This exponential only the type I'll show you, so no problem. But anyway, I know you came from that because you make the t table wrong. Right, check? Oh, I thought you raised your hand. Okay. What is the HA? -1. Very good. Give 1 point for Joshua. I didn't ask you to raise the ball because I didn't see anyone who got it right.
It's -2, -1 minus 1.
Oh. Hey, but that's right.
Oh, actually, Matthew got it right. Okay. Okay, let's give Matthew 1 point. Okay, there we go. Here we go. Okay. Give Matthew 1 point. What is the number you want to put into the table? Same thing, right? -1, 0, and 1. When you plug in -1, let's see what happens. So I copy everything the same, but now accept the x and put -1. A lot of you got this one too. So negative and negative become positive. So you have -2 minus 1, which is -3, right? A lot of you got this one. This one is one of the tricky one, but you got this. Now 0. Let's see, when you plug in 0, what is happened? What is this? Some of you, I saw that you put 0. Some of you, I saw that you put -1. Okay, so what is this then? What is -0? It's still 0. All right, good. So that's mean -2 to the power 0. Now, everything to the power 0 is 1. So this whole thing equal to 1. Is that correct so far? No. You still have the negative in here. Don't forget the old friend here. Okay. So the answer should be -2. I think only Matthew got it right. So 0, -2. Now x equal to 1. So -2, negative. Now you put 1 here. -1. What is 2 to -1? Again. Who didn't get point today? Ramon, Jose, huh?
Hey, wait. Hey.
One answer?
Okay. I think it's 2.
Okay, Jose, do you have any answer? You're good. You need to pay attention to get the answer.
I know it is. It's 2.
2 to -1.
Yes.
What is that?
You know why? Because
No, 2 to -1 is
2.
not 2.
What's that 2?
Not 2. Jose, what is the negative 2 to -1? 2 to the power of -1. Ramon? 2 to the power of -1. Ruby, what is 2 to the -1? All right, Karen, what is 2 to the -1? Joshma, 2 to the -1. 1/2. Let's give Joshma 1 point. The negative means you flip the number, okay? All right, Jose? All right, Ramon? Karen? Ruby? Yeah? So I hope you keep that in mind. So negative means you're going to flip the number. So 2 to -1 is 1/2. So keep everything the same as the negative -1. What is negative 1/2 minus 1? Negative 1.5, right? So same sign, you're going to add them together. And you keep the same sign as well. So negative 1.5. That's it. You can plug it in. So -1 and -3. This one is -1, so -2, -3. So right here. 0, -2, right here. And 1, -1.5. So 1 right here, 1.5 around right here. Okay. So this is the correct graph. All right. Last one. Just copy down, and then work on the last one. This one I'm going to help you with the starting first, because that's one thing you need to do first. All right, Jose Ramon, let's pay attention here. This is the last one, okay? What do you think is the first thing we should do first? Jasmine, Ruby? Oh, answer me. Let's look at this problem right here. What is the first thing you think that we should do first? Before anything else?
Divide. I don't think it is.
What is the difference between this problem and the other problem?
Oh.
What do you want to do about this? Huh? Well, decimal not gonna help, but yes, you're gonna convert the fraction. But how you convert it? So let's write a note right here. Always convert fraction. So 1/4. Is there any way you can write them as the non-fraction? We just did it. Like 2 to -1 become 1/2. So 1/4 is 4. 4. Just 4. So you just make 1/4 become 4. 4 to the power negative? Huh? Wow. So this whole table will come up with the correct answer. So 4 to the -1. Good. That's good. All right, let's go off you 1 point. That's good. So 1/4 is 4 to the negative. Negative what? Do you remember the rule we just talked about here? If you have the fraction already, if you want to change it, then you just change the negative become positive or the positive become negative to flip the sign. So similar to the one that we just talked about, -1. So 2 to -1 is 1/2. Do you agree? We just talked about it. So now we have 1/4. We can just convert them to 4 to the power -1. Does it make sense? Kind of. 4 is 1/4 to the -1. Or 1/4 is 4 to -1. Negative power, you need to flip it. No, that's not, this is not new. This is the old thing. When you want to flip the number, you make the power to become negative. Because the negative power means you flip it. It's the same thing. Yeah, it's the same thing. Yeah. So I want to change 1/4 into something non-fraction. I put it at a non-fraction, but the power, I flip the sign. The sign right here is 1, invisible 1. Okay, the sign right here, invisible 1. So when I flip it, it becomes -1. Make sense? So, but now outside is still outside. You still have -x outside, -x outside. What do we do? What do we do with this power like this? Power of power. That's what they call. Do we add them? Do we multiply them? Do we subtract them, or you divide them? What do we do? Who say we add them? Who say we multiply them? You have two votes. Who say we subtract them? Oh, what did you raise in? About which one? I didn't see. Add, multiply. I have two only. Okay, 4. Okay. Subtract. Divide. A lot of you don't care. Look at Amy. Amy we multiply. When two power next to each other, we multiply. Okay. So -1. What is -1 times -x? Just x, right? Negative become positive, right? So this is just x. Now, did you see this one? It's just similar to the one we just did, even better, even less complicated. So now you can start working on it. So the point for this example is that you need to always convert fraction into the non-fraction. Okay, maybe to make sense, convert fraction into non-fraction. All right. Now I'm gonna give you 4 minutes to wrap this one. Let's go with the last one we're going to do today.
I just turned my to fucking call this next.
I think I should remember.
It'll be 2. Where did you get -1/4?
Well, she having fun wrapping.
Wait, -1 was that last time?
Oh. No.
So all -1, so they call -4.
It'll be 1.75.
So favoring thing is so
So this is the oh, so it decides to.
Not 1%.
Yeah, you should say
Not 1%.
temper class.
Okay. Don't scare me like that. I'll be like,
But that outside. Yeah, do we don't give what? Do we don't give what?
-1. 1.7.
Oh, I haven't given you the homework yet. How do you have it? Yeah. Let's
They give
start.
us that stamp
Oh, the
sheet.
period. Oh, the stamp sheet, you lost it already?
No, it's here, it's here, it's here. And then one, two.
This is nothing to do. Only have the negative on power.
Negative one.
Only the negative on power, then you flip them. Negative 4, it's just negative 4. Like, he's using between the picture.
I think
This one was this one.
10 more seconds. What do you got? Right. You only do it when there's a statement. Not the negative on the number. The negative on the number doesn't do anything. You need more time? I think so. One more minute. All right, one more minute. I see a lot of you got the HA right though. I don't know. Oh, okay.
the lines like not that with the numbers. Like that is like
What is HA mean again? Can the wrap ever cut it? The wrap can never cut it. Like what I said, yeah. The wrap can never cut the HA. Okay, now you raise it. All right, raise the ball. 1, 2, 3. Everybody, raise the ball.
It is technically not cutting it. It is technically not cutting it, mister. I went.
Okay, that's okay. But yeah, she actually raised it. Now look like very weird. Okay, are you ready? I like me trend. Okay, let's skip Emily, Amy, Adam. That's all that's all I see. Okay, now let's do it. Wait. Okay, all right. Give Alex 1 point. Richard, do you have it? Okay, 1 second pass. All right.
Oh.
All right. What is the HA? 2, right? 2. Okay. If you make a mistake, again, it just came from the T table, the calculation. Okay. So same thing. You wanna put -1, 0, and 1 here. For -1, I'm plugging in x by -1. Let's see what happened. What is 1 to -1 again? What is 4 to -1 again? 4 to -1. Jose, what is 4 to -1? This is the second time I ask you. Ramon, 4 to -1. Ruby, 4 to -1. 1 over -4. Karen, 4 to -1. Huh? Okay, Jose. Pay attention. This is the second time I ask you. The negative power, you flip the number. So what is it then? What is 4 to -1? 1, 4. Yeah, Ramon? All right, Ruby, what is 4 to -1? He just said it. Okay. Karen, what is 3 to negative 1? Flip it. 1 over 3 to negative 1. 1 over 3. Yeah, you got it? 5 to negative 1. 1 over 5. You got it. So 4 to negative 1 is 1 4. 1 over 4. What is 1 over 4 plus 2? So 1 over 4 around like 2.75, right? 0.25. So 1.75. You can use calculators, but it's exactly 1.75. Now, why when x is equal to 0, what is that? How do you get 1? 4 to the power 0 is 1, but then you have a negative on the front. So negative 1 plus 2 is 1. Who said 1 is right? Okay. Now 1, plug it in 1. Did you get this one? Did you get the same number? Okay. Because so you got the wrap like over the line. That's something. Maybe some calculation was not correct. 4 to the power 1 is just Ramon. What is 4 to the power 1? That's negative 1. 4 to 1. Karen. Everything to the power 1 is 1, 0. Everything to the power 1 is same number. Ramon to the power 1 is still Ramon. Make sense? Everything to the power 1 is just same. No changing. Everything to the power 0 is 1. Yeah? So 4 to the power 1 is, Ruby, what is 4 to the power 1? 4. So I still have negative in the front. Negative 4 plus 2 is 2 or negative 2? You keep the same sign with the bigger number, okay? The bigger number here is 4, so you need to be the same sign with the 4, which is negative. So negative 2. Now you have the 3 point ready. Let's plug it in. Negative 1 is here. 1.75. That's lower than 2. So it needs to be lower than 2, like this. 0 and 1, 0 and 1 right here. This is 1, this is negative 1. 1, negative 2. So 1 here, negative 2. Let's say it's right here. So the wrap should be look like this. Yeah, make sense? All right, let me see. From 1 to 5, 5 would be extremely, very, very, very difficult. And 1 it should be, 0. 0 would be, you can do in your eyes, with your eye closed. How difficult is this? 10. Show me your finger, everybody. Show me your finger. Matthew, let me see. Okay, Karen. Only one hand allowed, okay? 0 is easiest, 5 is difficult, the most difficult. All right, okay. Ruby? Okay, so about it's different. About 2, 3. All right, that's it. That's it. Now, Alex, you can go to see Miss Satya. It's due Monday. It's due Monday. What Monday? Okay, here what we're gonna do Monday. Okay, maybe you can say this. So here's the schedule we're gonna do for the next 3 weeks. Next week, we're gonna have a quiz on Friday. The quiz very short, 2 questions only. Only 2 questions, front and back. But ABCD, just 2 questions. I'm gonna let you maybe 10 minutes or 15 minutes. Okay, next Friday. Today 9 Monday, we don't talk about presentation skill for your project. Okay, I'm gonna show you how you're gonna make engage to the student, to audience. What should you do and what should you not doing when you present? Okay, so we're gonna spend the time on Monday because Monday is short day. Not short day, only 1 hour. We're gonna do that. Okay. No matter what you want, because presentation is a good skill. No matter job you land or no matter where you go, you still need to present. Present to your customer, present to your manager. You know what I mean? Yeah. So you all need to practice that skill, public speaking. And here in the class, it's all your friend. We're very supportive here, no judging. So you should practice here, okay? What's it? Hold on, let me finish. And then next week, the week after, we just continue on the 9. 19 is the last week of the unit 9. We have another quiz. Again, short quiz, just 2 questions. Same thing for these 2. Okay? No unit test, and then we just do final. Sound good? All right. Oh, thank you.
What is he meaning by the decimal subtraction? Every
Decimal is 1/4. 1/3 is decimal, right? 1/3 is 0.3. Huh?
There is no decimal.
Oh, I see. Maybe it is in the top. Maybe this is the power of 16.
Oh.
Okay, if you're done, can you put the video one back? But if you want to use that for your homework, that's fine. But in the end, this actually is good. All right. You can use the time to do the homework. I recommend because you do it right now. You still remember. You just spend the weekend, you come back. I don't think you're gonna remember more like today. So how about just get it done?